Everyone, welcome back. We are starting a new unit. It's gonna be short and sweet. It's just gonna be two lessons, I guess. So we'll do one today and then one more next week. Okay, so we are actually gonna be graphing the next 2 weeks. Okay, so there's my name, Mr. H. Okay, so we are going to quickly review on how to plot points first. Okay, I believe you learned this in elementary school. But let's just quickly review. So here it says plot the following points and identify the shapes by joining points. So the first one, we have 4 points, right? A, B, C, D, A, B, C, D. Recall, this is what we call the coordinate pairs. And the first coordinate is the x coordinate, and the second one is the y coordinate. And remember, on the grid, the horizontal axis, okay, so this horizontal axis is the x-axis. The vertical axis right here, this is the y-axis. Okay, so the first point, A, is 3, 2. So that means the x-coordinate is 2. So that's right here. And the y-coordinate is 2. Wait, did I say 3 or 2? I think I said 2. The x-coordinate is 3, and then the y-coordinate is 2. So here's my x-coordinate of 3 here, and then I'm going to go up to the 2 right here. So this is my point A. As you can see, at this point, the x-coordinate is 3, and the y-coordinate is a 2, right? So this is our point A. Similarly, you can do the same thing for point B. The point B has coordinates of 3, 7. So x has a coordinate of 3 and the y coordinate 7. So that is right here. Okay, again, this you can see x coordinate is 3 right here, and the y coordinate is right here at 7. Okay, you can continue with point C, -2 and 7. So my x coordinate is -2. So that's right here. My y coordinate is 7. That's right here. So that's right here. This is where they intersect, right? You can see the x coordinate, if you move down, that's a -2. The y coordinate, if you move across, that's a 7. So this is point C. Finally, point D is -2 and 2. So x coordinate is -2. The y coordinate is 2. That is right here. And this is D. Okay, so if I join them, these 4 points together, so A to B, B to C, C to D, and D goes back to A, you can see this is a square. And we know this is a square because you can see this is 1, 2, 3, 4, 5 boxes, and that's also 1, 2, 3, 4, 5 boxes. So it's 5 by 5, right? It's a square, perfect square. Okay, so ABCD is a square. Now why don't you give it a try and plot WXYZ and see what shape it comes out to be, okay? I'll pause. You can pause the video and try it. I'm going to change the color. Okay, so hopefully you finished plotting the next 4 points. I'm just going to do this here. W is 1, -2. So again, x is 1 and y is -2. That is right here. This is my W. 4, -2. That is right here. Again, x coordinate you can see is a 4. Y coordinate is -2. This is x. My y, 6, -4. So here's 6 for the x. And the y coordinate is -4. That is right here. So this is y. Finally, z is -1, -4. So x coordinate is -1. That is right here. And y is -4. So we move down 4. So here's my z. Now we can connect these 4 points. W to x, x to y, y to z, and back to w. Do you remember what this shape is called? This is a trapezoid. Oops, that's not how you spell trapezoid. Trapezoid. Okay, so that's how you plot points. Okay, now these are simply just points. On the next page, we are actually going to look at the table of values. So this is what we call the table. This is what we call the table of values. And we're going to plot these points on a grid. Okay, now here are a few things that we need to keep in mind when we graph. Okay, so first, I mean, in this case, there is no context to these points. So we didn't really need to do this. But on the next page, first, what you need to do when you graph is you always give the graph a title. So always give a title. Give it a title. Okay, that would be the first thing I would do. Okay, so first thing is give it a title. Second thing, label your axes. Label your axes with units. Okay, now again, in this case, x and y, we are just plotting points. There weren't really any context to it, so you don't need to label axes with units. However, in this case, you can see there are actually some units here that we should use. You can see, okay, example, you can see clear. The units here is dollars, kilometers, right? So you can definitely see units. So make sure you label your axes with units. The third point, you have to keep in mind, right? Remember, so I guess we talk about axes. Well, then which one is which? Remember, horizontal axis, this is x, and vertical axis is the y values. Okay, so horizontal is x, vertical is y. And finally, we have the coordinate pairs, x comma y. Or I guess that's clear. That's x and that's y. I don't know why I drew an arrow here. Okay, so x comma y, right? The first number is the x value. The second number there, the second coordinate number is the y value. Okay, so x comma y. And again, x is the horizontal axis, y is the vertical axis. Okay, so those are the things that you gotta keep in mind. Okay, so let's look at the first example that we have here. We have okay, so again, this is what we call the table of values. Table of values. Okay, because you can see it's expressed or it's shown in table. Okay, so we have frame numbers 1, 2, 3, 4, 5, 6. We have the perimeter. It does not really give us a unit here, so it's just 4, 8, 12, 16, 20, and 24. So the title of this graph would be frame number versus perimeter. So that would be the title for this graph. Okay, this is horrible. I'm gonna write it better here. Frame number versus perimeter. Okay, so again, usually by default, okay, so this will be our x and this is our y. We call this the independent variable. And we call the y values, or the y variable, this would be the dependent variable. Okay, so our independent variable is always x and dependent variable is always y. So here is my frame number and this is my perimeter. Now again, this time there is really no unit in this case, so we don't need to give a unit in this example. So we have frame number 1, 2, 3, 4, 5, 6. So I'm just gonna call this 0, 0. So here's 1, 2, 3, 4, 5, 6. So I finished labeling my x-axis. Now, if you look at our y-axis, it goes from 4 all the way to 24, and you can see we don't have enough boxes to cover, to go up to 24. So what I'm gonna do in this case, I'm gonna go up by, okay, let me just count first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm just gonna say that each box is worth 2. Okay, so this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, I'm going to erase this first. 22 and 24. Here's my perimeter. Okay, I need more space. Here is my perimeter. Okay, so then I can plot the points. 1, and again, remember this is x and this is y. So 1, 4. So here's my first x coordinate of 1. And the y coordinate is 4, so there's my first point, 1, 4. 2, 8. 2, 8 is right here. 3, 12, that is right here. 4 comma 16, that is right here. Again, the x, you can see from this point, the x value, the x coordinate is 4, the y coordinate is 16. 5 comma 20, that is right here. 6 comma 24 is right here. Okay, now I guess after you plot these points, you might ask yourself, or you might be wondering, should I join these points? Okay, now in this case, the answer is no. Okay, we wouldn't join these points, and that is because, well, this is what we call a discrete data. Okay, so whoops. Okay, discrete versus continuous. In this case, our data is discrete. Okay, our table value is discrete because for the frame number, we can't have 1.5 frames. We cannot have 1.321 frames. We can only have like whole number of frames, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or even 0. But you can't have 1.321. You cannot have 5.62357 frames. Okay, so in that case, it's called discrete. Okay, in that case, we don't join the point. If it's continuous, then we could. Okay, maybe we'll see some examples of continuous data in a second. Okay, but that's the first example. Okay, let's look at the second example. I'm going to do in red. Okay, so the second example, in this case, we have distance. Again, this is our x, and here's our y. So this would be our distance versus cost graph. Okay, so here is my distance. And again, this time, because we do have units, so we need to put units in the bracket, kilometers. And we also have the cost, and the unit is in dollars. Okay. Okay, so now we will need to scale the axes once again, because you can see the distance goes from 0 to 400. There's absolutely no way there are 400 boxes here. So in this case, I probably would make each box worth 50. Okay, so I'm going to say that's 0. And if I make each box worth 50, then that means 2 boxes worth 100. So that's 100. This will be 200, 300 here, and 400 here. We can extend a little bit more. That's okay. Even though we don't need it, that's okay. For the cost, I would probably say each box worth $20. Okay, so that will be 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Okay, that's probably good enough. Now I am going to plot the points. So when it's 0 for the distance, the cost is $60. So that is right here. When the distance is 100 kilometers, the cost is $80. So that is right here. Distance 200. Okay, so here's my x being 200 here. And the cost is $100. That is right here. 300 and 120. That is right here. Okay, you can see the pattern. When the distance is 400, the cost would be 140. That is right here. Okay, so what do you think? Is this a continuous graph, or do you think this is a discrete graph? We're talking about distance and cost. What do you think? So again, discrete versus continuous. Okay, so the last one, it was a discrete graph. Okay, this time, I believe it's a continuous graph. Okay, it's because we can actually drive 122.33751 kilometers, and the cost could be $61.321005. Though we round it to the nearest cent, but I mean, you can see the amount here, it could be, or the units here could be continuous, right? It could go to very long decimal places, and that's okay. So in this case, it's a continuous graph. So I am going to actually connect the points in this case. And you can see when you, I should use a ruler, but you can see there's definitely a pattern in this graph. And you can see when you join them together, it's actually a straight line. Okay, it's a straight line. I mean, if you look at the first graph, if you were to join the points together, you can also see this is also a straight line. Okay. All right, the last example here. We have the time and we have the temperature. Here I'm gonna again use a different color here. So this would be time versus temperature graph. Temperature. We have our time as again, first column is the x-axis. So here is time in minutes. Oops, I don't need the brackets for time. Time in minutes. We have the temperature here. Temperature in degrees Celsius. Okay. Now let's see. We have the time. It goes up every 5 minutes. So then in this case, I would probably make each box worth 5. Okay, it's nice and easy. So that'll be 5, 10, 15, 20, 25, 30. That's probably good enough. For the temperature, the highest point here is 29. And the lowest is 9, so I would have to start from 0 and go up to 30-ish. So I'm gonna just make each box worth 3, okay? Because I know there are 12 boxes here. So I'm gonna say that's 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. Definitely don't need that much, but that's okay. Okay, so I'm gonna plot the point. 0. When the time is 0, the temperature is 9 degrees Celsius, so it's right here, 0,9. Time is 5 minutes, temperature will be 13, so 5, and that's 12, and that's 15. So 13.5 is actually right in the middle, so just a little bit below the halfway point, I guess. 10,17, so here's 10 for the x value, 17, here's 18, and here's 15. So 17 will be somewhere here, about 2/3 way, right? Actually, exactly 2/3 between those two lines. 15, 21, so here's 15, here's 21 for the y value, it's exactly at the intersection right there. 20 and 25, so here's 24, so it'll be 1/3 way, because it's broken into 3 parts, right? 24, 25, 26, 27, right? 25, 29, so that'll be 2/3 way right here. Okay, so here are my points. Again, do you think we should connect them together? I believe so. Okay, I think we could. Again, I think these units would be continuous. This, I think it's continuous as well. Continuous as well. You could definitely have 3.21721 minutes. I think that's fine. You could also definitely have 15.3721 degrees Celsius. That's okay. Okay, so I think this will be continuous as well. So I'm gonna join them together. Okay, so something like that. And again, you can see it's a straight line. So anytime when you have a table of values or some sort of equation, which we'll be seeing next lesson, and that when you plot them, it gives you a linear kind of shape. This is what we call a linear relation. Okay, linear relation. It's a linear relation. So the 3 equations or 3 graphs that we did today, or that we graphed, they were all linear relations because you can see it. It's a straight line. Okay, so it's a linear relation. Okay, so that is it for this lesson. You have the rest of the handout for you to do. Let me know again if you have any questions. Okay, otherwise that's it. Good luck.